Hello guys, welcome to my YouTube channel Matlab Explorer. Today we are going to discuss the application of neural network in industrial process. So the problem statement here is here the description is industrial production of compressor suffers from the problem of imprinting force and in compressor production normally what happens, compressor gets cracks and some overload condition. So these defects are the overload defects and cracks are bit difficult to detect, but for by using the application of neural network we can easily detect these defects and cracks. So we are going to show you how we can apply neural network. This is the practical application of neural network in industrial production process. So these are some sample images. So here is the image of a compressor. Here you can see this is the breakage of the compressor, and this is the crack. So here you can see the crack overload condition. So neural network is gonna detect both with high accuracy. That is what we are gonna see. So here first we have a data file and we have to load it. In data file we have the parameters okay, overload, crack. So these three variables we have to check the condition of the compressor, whether it is okay, overload, or in a crack condition. Alright, we will see here. First we have to load the file, load data to.mat. So in this file we have the data where we have a parameter force, we have a target file, and the condition, whether it is okay here like this, whether compressor is okay, overload, or in crack condition. So we are going to plot it, and we will see the initial plot of these variable data. So try to run this one here. So here these three variables, force, nodes, and nodes contain the condition whether okay, crack, or overload. So this is the target. So it contains a 2000 into 100 vector, 1 into 300, 2000 into 1 vector. So this is the byte size class. So these are the initial graphs of the data file. Here you can see. So so this is the force colored C, and the target is like 1 2 3, means okay, overload, and crack. So this is the condition, whether it is like this is for okay. This is the data of force, and this is the data of okay variable. I mean these number of compressors are okay. Here same overload. This is the force, this is the overload condition. Here we can see here force, crack. So this is the variation of force and time, you can see here. So this is the initial, and so next we have to resample, because it was bit long and we have to resample it with a step size 10. Here again we have to plot on the same plot diagrams. Again step here. Now first the time was between 0 to 100, now it is 10. So to give a very clear picture of the data, resampling. So this is overload condition. Here you can see this is how the force makes the overload condition. Again crack, and this is okay. Here you can see time versus force. so here we have to create it. We have to create the network first for this application. Here we create it, we try to run it. We have to create the neural network to detect the condition crack, overload or okay in the piece of compressor. Here we will create the network. Here you can see creating and training. Okay, create and train a multi-layer perceptron. Okay, here you can doing it with the training set 70%, 15% validation and 15% test. So here you are training the neural network. You have to check out the performance. And now you can apply it. Application. So this is how. 0 means okay. 0 means okay condition. Now it is able to detect how many pieces are okay in a sample of all the compressor products. It is the neural network is able to detect the correct number of pieces. So and here also performance, you can check out the correct classification percentage. You try to run this variable, what percentage they are able to classify. 99.8. Here you can see the classification accuracy. This is how you are able to detect the correct number of pieces among the sample of with overload, with crack and with okay condition. So this is how you use neural network to for the classification problem of. You can use this for your research purpose also. And make sure you like share and subscribe the YouTube channel, and to get to know more about the application of neural network, about the Matlab working its different toolboxes. You can follow us on Facebook also, our Facebook page Matlab Explorer and YouTube channel Matlab Explorer. So hope you like the video. Thanks for tuning. Thank you.